Hi to all. Now I am discussing about series connection. Series connection of passive elements. Passive elements. Series connection of passive elements. So what are the passive elements? Resistor, inductor and capacitor. So before going to the series connection, we need to consider, we need to know about the voltage across, current through each element. So coming to resistor. So resistor voltage equals to I into R. Now coming to current I equals to V by R formula. Now coming to capacitor. Okay, so resistor voltage across resistor is V equal to I into R, current I equal to V by R. Okay, now coming to capacitor. So voltage across capacitor is current through capacitor I equals to C into dV by dt. Now coming to voltage 1 by C into integral of I dt. Okay. Now inductor. So inductor V equals to L into di by dt. Now current expression I equals to 1 by L into integral of V dt. Okay. So voltage across each element, current through each element completed. Those are passive elements: resistor, inductor, capacitor. What is the unit of resistor? Ohm. What is the unit of capacitor? Farad. What is the unit of inductor? Henry. Henry is the unit of inductor. Now coming to what do you mean by series connection? So series connection is, here suppose I am considering resistors are in series. Resistors are in series. Okay, suppose I am considering two or more resistors. Here R1, R2, R3. Okay, now it is connected to a active element, that is voltage source. Okay, now each element having two terminals. Okay, so one is here, this is 1, 2, and this resistor having 1, 2 terminals, and it is also having 1, 2. This is R1, R2 and R3 resistor. So each element having two terminals. Now first element, first terminal, this is second terminal. Second element, first terminal, second terminal. Third element, first terminal, second terminal. So now the first element, second terminal is connected to second resistor, first terminal, and second resistor, second terminal is connected to third resistor, first terminal. Like that it is going on and connected to a supply. Then it forms a closed path. Now these resistors are in series mode. Now R1, R2, R3 are series connected through a DC supply. So here I am applying V total voltage. Now when I am applying some voltage with the help of this supply, here we get some current, that is I. Now in a series connection, voltage must be divided. Why? Because voltage is nothing but potential difference between any 2 points. So here voltage across resistor 1 is V1, voltage across resistor 2 is V2, voltage across resistor 3 is V3. Okay. Now total voltage Vt is equal to sum of individual voltages. Okay, so sum of individual voltages. Now in a series circuit, current equals to, it is a single flow of current, there is no diversion. So from positive to negative, only one path direction is available. So current through R1 is I1, current through R2 is I2, current through R3 is I3. If suppose n number of resistors are connected in series, now n currents are possible, so that is In, it must be equal to total current. Why? Because in a series circuit, current must be same, voltage must be divided. So now here the total voltage must be equal to V1 plus V2 plus V3 plus so on plus Vn. If n number of resistors are connected in series, the voltage across each element must be added. Okay, so now coming to resistor. In a resistors are in series connection. Now it is in series connection. Now we need to consider the total resistance when these resistors are connected in series. Now with the help of voltage equation, here according to ohms equals to, we can write it as I total into R total according to Ohm's law. Now suppose I am considering V1. So V1 equals to I1 into R1. V2 is nothing but I2 into R2. If Vn equals to In into Rn. Like that we can split each V1, V2, V3, V total based on the Ohm's law. Now just substitute this value in this expression. So from V total, so what do you mean by V total? Total voltage. So how much the total voltage according to Ohm's law? That is I total into R total. Now coming to V1. V1 is nothing but what? I1 into R1. Now coming to V2. V2 is nothing but voltage across resistor 2, that is according to Ohm's law I2 into R2, then voltage across resistor R3, that is I3 into R3. If n number are connected in series, then we get the In into Rn amount of voltage. Now just I can say that I1, I2, I3, In is nothing but I. So substitute in this expression, then we get I total is nothing but what? I only. So that is I into R total. Now I1 is also nothing but I into R1 plus I into R2 plus I into R3 plus so on plus I into Rn. Okay, now I can get common here. I equals to R1 plus R2 plus R3 plus so on plus Rn. Now coming to left hand side, I into R total. So I total and I get cancelled. Finally we get R total. R total equals to R1 plus R2 plus R3 plus so on Rn. So this is the total resistance in series connection. Okay. So what is the unit of resistance? Ohm. What is the unit of resistance? Ohm. So now 3 resistors are connected in series. If n number of resistors are connected in series, what is the total current? That is must be same as I1, I2, I3, so on, In in a series combination gives I only. Now coming to voltage, voltage is nothing but it is the potential difference between any 2 points. So here resistor 1 having 2 terminals, R2 is also having 2 terminals, R3 is also having 2 terminals. So that's why the total voltage is divided into 3 parts, that is V1 plus V2 plus V3. Now in a series connection, voltage can divide I must be same. So for that consideration, I total equals to this equation, V total equal to V1 plus V2 plus V3 so on Vn. So based on this equation, just substitute according to Ohm's law, V equal to I into R formula, then we'll get this equation, I total into R total equal to I1 R1 plus I2 R2 plus so on In Rn. Now in a series connection, current must be same. So just I can take the common as I. So I get cancelled. Finally we get R total equals to R1 plus R2 plus R3 plus so on Rn. So resistors are in series. So in series resistance, that is nothing but R total equal to R1 plus R2 plus R3 plus so on Rn. Now coming to next one, inductors are in series. So this is resistors are in series. Now coming to inductors. Okay, so inductors are in series. So here second, inductor means L's are in series. Inductors are in series. Now I am considering 3 or 2. Now here this is inductor symbol L1, L2 and L3. I am considering 3. Let us assuming 3 inductors are connected in series. Okay, so here the applied voltage is V total. Now this is L1 and it is L2 and it is L3. L1 means inductor 1, inductor 2, inductor 3. And these also having two terminals, here also two, here also two. So that's why now voltage across each element is V1, this is V1, this is V2 and this is V3. Okay, but current must be same in series connection, same formula, current must be same, voltage is divide condition. Now here what is the voltage across inductor ma, that is L into di by dt. Now here I am considering V total equals to, V total is equals to, what is the formula ma? V total must be equals to V1 plus V2 plus V3. If n number of inductors are connected in series, consider as Vn. Now coming to current, it is also a series connection. So current must be same, only single path. So I total is nothing but this is I total. I total equals to I1 equal to I2 equal to so on. In is equals to I only. Why? Because it is a series connection. Now from voltage equation, so what is the voltage across inductor ma? L into di by dt. So by using this formula, V total equals to, how we can write here? That is V total is nothing but L total into di total by dt. Like that we can write. Now coming to V1. V1 is nothing but L1 into di1 by dt. Okay. So based on this formula, we can write V1, V2, V3, so on, V total. Now just to substitute this value in this equation, consider equation number 1. So from equation number 1, V total is nothing but what is the formula ma? L total into di total by dt, di total by dt. Now equals to, okay, what is V1? L1 into di1 by dt. Okay, now second one, V2 means L2 into di2 by dt plus so on plus Ln into din by dt. Din by dt. Now coming to current equation, so current must be same in each element. So current consider as common here. So resistors are in series. What is the equivalent resistance? That is R total is not equals to R1 plus R2 plus R3 plus Rn. So on Rn ohm. Now coming to inductor. So in inductor, L total is nothing but here L total into di total by dt equal to L1 into di1 by dt. But the current must be same. So I total equals to I1 equals to I2 equals to so on, In is equals to I only. So just to substitute this current value here, then L total into di by dt on left hand side. Now coming to right hand side, that is L1 into di1 is also I. So di by dt plus L2 into di2 is also I. So di2 by dt plus so on plus Ln into di by dt. If n number of inductors are connected in series, in that case I am considering this term. Now all I di by dt, di by dt, di by dt, di by dt, this can get cancelled. Okay, left hand side, right hand side get cancelled. Now L total is equals to, remaining terms are L1 plus L2 plus so on plus Ln. So in a series connection, if inductors are connected in series, the total inductance is equals to L1 plus L2 plus so on Ln. What is the unit of inductance ma? Henry. Okay, so this is the series connection inductance. Okay, so three inductors, suppose here I am considering three inductors are in series. What is the equivalent inductance? L total equals to L1 plus L2 plus L3. If 4 are there, consider L4. Like that we can consider each element, those are connected in series. So here inductors are completed. Now coming to third element, that is capacitor. So capacitor, it is also a passive element which stores the energy in the form of electrostatic field. Now what is the unit of capacitor? The unit of capacitance is farad. Okay, now here third consideration, that is capacitors are in series. Capacitors are in series. Again I am considering capacitor element. It is a passive element. It is formed with two parallel conducting plates. Those are separated with dielectric media. Okay, this is one capacitor and this is second capacitor. Okay, now third capacitor. Okay, two parallel plates. Now it is connected to source. Okay, this source is V total. Now this is C1, C2 and C3 element. Three capacitors are connected in series with a supply voltage of V total. Now voltage across C1 is V1, voltage across C2 is V2, voltage across C3 is V3. Now it is a series connection. Now the current flowing through this circuit is I total. Okay, now coming to series connection, I total is equals to I1 equals to I2 equals to I3 is equals to so on equal to In. Current is in same path, only single path is available. Here there is no separate path to divide, only single path from positive to negative. So consider each element current is I only, that is I. Okay, now coming to voltage. So V total is equals to sum of individual voltages. So V1 plus V2 plus V3. If n numbers are connected in series, so consider as Vn. Now coming to voltage equation in capacitor. So what is the voltage equation in capacitor ma? That is 1 by C into integral of I dt. So voltage across capacitor is 1 by C into integration of I dt. This is the normal formula, voltage across capacitor. Okay, so just substitute this value here. So V total is nothing but 1 by C total into I total into dt. V1 is nothing but, so like that, just split it here. V total is nothing but 1 by C total into integration of I total into dt. Then coming to V1. V1 is nothing but 1 by C1 into integration of I1 into dt. Okay, like that we can consider each voltage response. Now, just substitute these values in this equation, equation number 1. So, from equation 1, okay, V total is nothing but, what is the response here? 1 by C total into integration of I total into dt. So, 1 by C total into integration of I total into dt on left side. Why? Because V total is on left side. Now coming to right hand side, that is V1. V1 is nothing but, what is the value here? 1 by C1 into integration of I1 into dt. Now coming to C2, 1 by C2 into integration of I2 into dt. If n numbers are connected in series, so on, plus 1 by Cn into integration of In dt. Okay. Now here in a series connection, current must be same, that is I total I1 equal to I2 equal to so on equal to In equal to I only. So just to substitute this value in this expression, here 1 by C total into integration of I dt. Okay. Now coming to right hand side, 1 by C1 into integration I dt plus 1 by C2 into integration I dt plus so on plus integration of 1 by Cn into integration of I dt. Okay, so now current get common here, just remove that, then we'll get 1 by C total is equals to 1 by C1 plus 1 by C2 plus so on plus 1 by Cn. So this is the series connection, the total capacitance in series connection in terms of farad. If n numbers are connected in series, the equivalent capacitance is equal to 1 by C1 plus 1 by C2 plus so on Cn. So, if suppose I am considering two capacitors are in series. So, what is the equivalent capacitance ma? Here, two capacitors. So, two capacitors for two Cs are in series. So, 1 by C total is equals to 1 by C1 plus 1 by C2 only. Now, just LCM. Take LCM here, C total equal to, what is the LCM? C1, C2. So, C2 plus C1. We need C total. So, C total is nothing but just denominator act as numerator, numerator, denominator. So, C1, C2 by C1 plus C2. Okay, this gives the total capacitance when two capacitors are connected in series in terms of farad. Okay, if three capacitors are connected in series, three C's are connected in series. So, what is the equivalent? 1 by C total equals to 1 by C1 plus 1 by C2 plus 1 by C3. Just do LCM here. So, C total, 1 by C total equals to 1 by C total is equals to LCM is C1, C2, C3. Now coming to numerator part, here C1 is there, consider C2, C3 plus C2 is there on second term, so C1, C3 plus coming to third term, C3 is available, so C1 into C2. So just consider C total here, that is this comes to numerator. So C1, C2, C3 by just write in order C1, C2 plus C2, C3 plus C3, C1. Okay, this is three capacitors are connected in series, the equivalent capacitance in terms of farad. Okay, so in series connection, so here inductors are in series, capacitors are in series, and resistor are also in series. So all are in series connection. So what is the equivalent resistance when series connection? R total equals to, what is the formula? So for series connection, for series, R total equals to resistor, coming to resistors, R1 plus R2 plus so on plus Rn in terms of ohm. Then coming to inductor, L total equals to L1 plus L2 plus so on plus Ln in terms of henries. Okay, coming to capacitor. So C total is equals to, here we can consider 1 by C total, that is 1 by C1 plus 1 by C2 plus so on plus 1 by Cn in terms of farads. Okay, so for a series connection, one main point is current must be same. In series connection, current is same, voltage must be divided. Okay, so V total equals to, we can write it as V1 plus V2 plus so on Vn. This is common for all three. Okay, and current is also same for all three cases. In a series connection, current must be same, voltage must be divided. Now we can get current and voltage, then we can calculate power also. P equals to V total into I total. If individual element we need to calculate, so that's why P, voltage P1 is nothing but V1 I1. Like that we can consider power in terms of watts also. So this is coming to series connection. Now coming to parallel. Okay, series connection completed. Now coming to parallel connection. So parallel connection of passive elements. So again in series connection, current must be same, voltage divided. Then coming to parallel. Now in parallel connection, if two elements are connected in parallel, okay, current is divided, voltage must be same. Why? Because voltage is nothing but potential difference between any two points. So here first consideration is resistors. So resistors are in parallel. Okay, so resistors are in parallel. I am considering two resistors here. So this is R1 and this is R2. Now this is the supply I am giving. Okay, R1, R2. Okay, negative, positive, this is V total. So this terminal is connected to here and this terminal is connected to here. Okay, R1 is having two terminals. This is positive first terminal, this is second terminal. Okay, it is also connected this point, some call it as A, call it as B. Now R2 first terminal is connected to A point, R2 second terminal is connected to B point. So potential across, voltage across R1 is same, voltage across R2 is same, voltage across total is also same. V total in a parallel connection, voltage must be same. Why? Because voltage is nothing but it is the potential difference between 2 points. Now the R1 two terminals are connected AB, R2 two terminals also connected AB, supply is also connected to AB terminals only. So all are in same consideration. So for parallel connection, voltage V total equals to, voltage across R1 is V1, voltage across R2 is V2. So V1 equals to V2 equal to, if n numbers are connected in parallel, that is equals to Vn, that is equal to V only. Okay, now coming to current. So here some I total is flowing. Okay, now it is a junction point. So I total is divided into two parts. One is flow towards the R1, consider as I1, and second current is flows towards the R2 resistor, that is I2. Okay, now I1, this is flows towards the through R1 up to B point and I2 is up to B point. These two are entering at this point. Finally, we get I total. Okay, so in a parallel connection, current is divided. So I total is equals to I1 plus I2 plus, if n number of resistors or n number of inductors or n number of capacitors are connected in parallel, current is in divided mode. So I1 plus I2 plus so on plus In, that is equals to, we can write it as based on the current flowing through resistor, current flowing through inductor, current flowing through capacitor. Now here two resistors are connected in parallel. So now what is the, according to Ohm's law, what is the current expression? I equal to, we can write it as V by R. Now just in this equation consider each individual values. So I total is nothing but we can consider it as V total by R total. Now I1 is nothing but V1 by R1. I2 is nothing but V2 by R2 plus so on plus Vn by Rn. Okay. Now here voltages are same. So final equation, V by R total is equals to V by R1 plus V by R2 plus so on plus V by Rn. So we get cancelled. Finally, R total is nothing but 1 by R total equals to 1 by R1 plus 1 by R2 plus so on plus 1 by Rn. Okay, so this is the total resistance when connected in parallel. In series combination, R1 plus R2 plus so on Rn. Coming to parallel combination, 1 by R total equals to 1 by R1 plus 1 by R2 plus so on 1 by Rn. If consideration of only two resistors are in parallel, then directly we can write it as R total equals to R1 R2 by R1 plus R2. Now, if three resistors are in parallel, three resistors, okay, R total equals to product of 3, R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1. So, this is parallel connection. Resistors are in parallel. Now coming to inductors are in parallel. Resistors are completed in resistor connection, parallel connection. 1 by R total equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on 1 by Rn. Ohm, resistance measured in terms of ohm. Now coming to inductors. So inductors are in parallel. Okay, now again same circuit but inductor element. We need to consider here inductor element. Okay, now this is L1, this is L2, again connected to a supply, negative, positive, this is V total. Same current I total, this is A point, this is B point. Here I1 is flowing towards L1, I2 is flowing towards L2. Up to here, again it is meted at this point. Finally we get I total. Okay, for a parallel combination, current must be divided. I total equals to I1 plus I2 plus so on plus IN. Coming to voltage, voltage is same. Why? Because potential difference between L1, L2, L3 are same. So, V total equals to V1 equals to V2 equals to so on. Vn equals to V only. Now, coming to current flowing through the inductor. How much amount of current flowing through an inductor? 1 by L into integral of V dt. So, current expression in inductor I equals to 1 by L into integration of I dt. Okay. So, here VDT, sorry, it is VDT. Okay, so based on this formula, we can write the current expression here, that is I total equals to, what is the consideration here? I1 plus I2 plus n numbers are connected in parallel, consider it as In. Now, based on this formula, I total equals to 1 by L total into integration of V total into dt, and I1 1 by L1 into integration of V1 into dt. Now coming to I2 1 by L2 into integration of V2 dt, plus so on, plus 1 by Ln into integration of Vn dt. Okay. Now in a parallel connection, as I told you, that voltage must be same. So here write it as 1 by L total into integration V dt is equals to 1 by L1 into integration V dt plus so on, plus 1 by Ln into integration V dt. So right hand side, left hand side, both voltages can get cancelled. Finally, what is we get 1 by L total is equals to 1 by L1 plus 1 by L2 plus so on, plus 1 by Ln. So this is the voltage total inductance in parallel connection in terms of henries. Again, if suppose two inductors are in series, L1 L2 by L1 plus L2. If three inductors are in parallel, so L1 L2 L3 by L1 L2 plus L2 L3 plus L3 L1. Okay, so inductors are parallel. So only one main point, parallel connection, current is dividing consideration, voltage is same in each element. Okay, so based on that, just I used this formula, that is I equal to 1 by L into integral of V dt. So just to substitute this value here, then we'll get the final expression of inductance. Okay, now inductors completed. Coming to capacitors. So capacitors are in parallel. So in capacitors, what is the unit of capacitor? So it is farad. Now I am considering capacitors are in parallel, C1 and this is C2. So C1, C2 are in parallel. So with the supply voltage V total. Okay. Now this is A terminal, again B terminal, C1, this is C2. Voltage across C1 is V1, voltage across C2 is V2. Now current flowing through the I1, C1 is I1, current flowing through the V2, C2 is I2. Okay. Now in this total circuit, that is I total current is flowing totally. Okay. Now in a series connection, as I told you that V total is equals to V1 equals to V2 equals to so on, equal to Vn, that is equals to V. Now coming to current, so I total equals to I1 plus I2 plus so on plus IN. Okay. Now coming to current expression in capacitor. So current expression is I equal to C into dV by dt. So I equals to C into dV by dt. Okay. Based on this expression, just to substitute this value in this expression, then we'll get the final total capacitance. So I total is nothing but here C total into dV total by dt on left hand side. Coming to right hand side, I1 is there. I1 is nothing but C1 into dV1 by dt. Now coming to I2. I2 is nothing but C2 into dV2 by dt. If n capacitors are in parallel, that is equals to Cn into dVn by dt. Okay. Now in a parallel connection, current must be divided, voltage is same. So again voltage can get cancelled here. So C total is equals to C total into dV by dt equals to C1 into dV by dt plus C2 into dV by dt plus so on Cn into dV by dt. Okay. Now dV by dt on left hand side and right hand side both can get cancelled. Finally C total equals to C1 plus C2 plus so on plus Cn. This is the total capacitance in parallel connection in terms of farad. Okay, so parallel connection capacitance, total capacitance equal to C1 plus C2 plus so on Cn. Okay, so parallel connection completed. So parallel connection, series connection, both are based on each element voltage and current expressions mainly. Now what do you mean by series connection? In a series connection, current must be same, voltage divide. Coming to parallel connection, current divides, voltage must be same value across each element. Okay. Now just a difference between series and parallel. Last one, difference between series and parallel. Okay, differences between series combination and parallel. So coming to series here, and here parallel I am considering. Series connection, parallel connection. Okay, so mainly in a series connection, current I total is equals to I1 equal to so on, I2 equals to so on equal to In equal to I ampere. A is nothing but unit, that is ampere. Coming to parallel. In parallel connection, I total equals to sum of individual I1 plus I2 plus I3 plus so on plus In. It is also measured in terms of ampere. Now coming to voltage. So in series connection, voltage is nothing but potential difference between 2 points. So now V total is equals to V1 plus V2 plus so on plus Vn. It is measured in terms of volts. Now coming to parallel. In parallel connection, total voltage is same as that of individual voltages. So V total equals to V1 equals to V2 equal to so on equals to Vn equal to V only. So it is also measured in terms of volts. Now if resistors are connected in series, okay, so what is the total resistance here? R1 plus R2 plus R3 plus so on plus Rn in terms of ohm. If inductors are connected in series, as I earlier told, IL total equals to L1 plus L2 plus so on plus Ln in terms of henries. Okay. Now coming to capacitor. So that is equals to here. Capacitor is opposite reciprocal of inductor element. So 1 by C total equals to 1 by C1 plus 1 by C2 plus so on plus 1 by Cn in terms of farads. Okay, this is the capacitor total capacitance when connected in series. Now coming to parallel consideration, 1 by R total is equals to 1 by R1 plus 1 by R2 plus so on plus 1 by Rn. It is measured in terms of ohms. Now coming to inductor. Inductors are in parallel. So 1 by L total equals to 1 by L1 plus 1 by L2 plus so on plus 1 by Ln in terms of Henry. In terms of Henry. Now coming to capacitor, it is reciprocal of those two. So that's why I am considering C total is equals to C1 plus C2 plus so on plus Cn. It is measured in terms of farad. Okay. So this is the difference between series connection and parallel connection of passive elements. Okay. So thank you one and all.